talk is not about how to use AI in theoretical physics or how to apply theoretical physics to explain why AI seems to work, but rather some tools in publishing, including in theoretical physics publishing. And so I will kind of come to what we're doing from kind of a very broad perspective. So this is pretty much like my attempt at summarizing history of academic publishing on one slide. So starting with the 1440, and actually John McGreevy told me I was wrong. So it was invented in the 13th century by the Koreans. The printing press, the first journal was published in the 17th century. Actually, this is this month's issue of the same journal. So the first peer review appeared in 1731, but it became sort of general system in the beginning of the 20th century. And around 1948, for-profit scientific publishing was invented sort of by Robert Maxwell, the father of Gillian Maxwell, you may have heard of. So if you're wondering where your money is going, that's where it's going when you pay for publishing. So the good stuff happened, I guess, around 1991 when Paul Ginsberg launched Internet Archive. But all in all, we're kind of using the same antiquated model, which has many problems. So in my opinion, the key problem is the exponential overflow of data. So here I'm showing monthly submissions to archive.org as a function of time. This is 1991. And this is the month of May. This is COVID plateau when there was no experiment. And this is LLMs, I assume. And in the month of May, for instance, there was 20,000 submissions. Is it a lot or not? I mean, let's ask AI. So that's what we do now, right? We don't have to think. So, and it gives a pretty reasonable answer. So actually tried both ChatGPT and just locally Llama 2 on my computer. They pretty much give the same results. 8 years. Yep. Yeah, but it does, but still. Well, I mean, you don't have to read them, but still, you know, the number is kind of staggering. So it will take you 7-8 years to read them. And if you don't like this example, suppose I want to read all COVID papers, which by definition papers published in the last 4 years. It will take you 150 years to read them. So this is just to give you an example of, you know, how much data there out there. So basically, you know, if you look under the hood, you know, I can't tell you exactly, but most papers are not even read actually at all. So, so you kind of assume that if you write something really, really deep and people will notice it, et cetera, well, it's just not the case. So, and well, if you want to read all the papers published today, it will take you 25,000 years. Well, good luck with that. So, so in my opinion, at least, so the last thing we need is LLMs generating more scientific content. So, who is going to read all this stuff anyways? So, well, this brings me to my second point. So, but yet this is exactly what's happening. For example, I'm a journal editor, and what I see clearly is that there's some LLM-assisted writing of papers. Suddenly I get like perfect English from authors who, you know, I was rejecting it because it was just completely, you know, meaningless. Now it's like Shakespearean English. And then I send it to rephrase. They clearly generated by ChatGPT. And then these guys respond by ChatGPT. So it's kind of a loop. So this is not like somebody said, if there is artificial intelligence, there's bound to be artificial stupidity. So this is pretty much that. So, but seriously, you know, where AI can be useful, in my opinion, is creating the content, kind of separating the wheat from the chaff, sort of, well, basically analyzing large amounts of data, for example, and that's sort of what we're thinking about, such as digests, kind of recommendation engine, perhaps, of what you may not be interested in doing and reading, rather, kind of going through this kind of pile of data, looking for gems. And, but on the other hand, whatever you build, it's very easy to buy such tools. And I can see it if you look under the hood, you know, I change one parameter, I get completely different result. So also where AI can be useful is in certain aspects of peer review process, not peer review itself. And in fact, I'll explain in a second that this problem of Netflix style recommendation engine is actually dual, quote unquote, to recommendation engine for referees. Now, let me just, because I want to have this a little bit of a rant. So what are we doing now in terms of what is the current publishing system? So first of all, it was invented by this guy who was actually convicted fraudster in 1940s. So before that, Fermi used to read all the papers in PhysRFB. It was basically published by professional societies. You know, but what is the business model? So the business model is the following: we write papers for free, we refer papers for free, we work as editors for free, and then we pay to read our own papers. You don't even notice that. But actually, in my university, where I'm a part of Library Council, our budget is $33 million. 30% of it goes to subscriptions. So it's about $10 million per university per year. So if you're wondering why you're here, overhead is 70%. Well, that's why. So you're actually paying to read your own papers. And then the total market of this is $25 billion. So that's how much for-profit publishers get. So every time you publish in Nature and brag about it, actually, well, I'm not so sure. So anyways, and there are about 30,000 science journals, and their profit margin is more than Coca-Cola and Google, actually. So more than 40%. So it's totally predatory system. But what do we get in return? Of course, we get peer review, which is so wonderful, as everybody knows. Like every time you submit to PRL, you get these wonderful reports telling you that it doesn't satisfy the criteria of whatever. So, well, we know it's not, unfortunately, the case. So, and actually, the federal government didn't care about it all that much until COVID happened. So COVID happened, and they started funding COVID research. And then some senators, who some of them can actually read, so they tried to read COVID papers, and they couldn't actually access them. And they're like, do we have to pay to read the papers? And they said, yeah, you have to pay like $20 per paper, or $10,000. And they're like, no way, so we're paying for this research, and we have to pay for this? No. So, and that's why there was this announcement called Nelson Memo in August 2020, last year, which basically says that everything has to be for free now. But obviously what it means is just we have to pay open access fee. That's what it actually means in practice. But, there is actually, there are a lot of initiatives, actual funding, serious funding initiatives by a lot of agencies. And they declared 2023 a year of open science, whatever the heck that means. So anyway, so kind of back to AI. So one idea, and in general, like what we're thinking about, is to kind of leverage things that actually work and kind of good. So, and these are archive, and there is also bioarchive, medical archive, other archives that are in fact free, and we use them. And so it would be kind of nice to create a substrate, if you wish, underneath these archives. It doesn't have to be AI necessarily, but some sort of useful substrate that would kind of eliminate the need for maybe external publishing eventually. And well, there are a few startups, including Xiaoliang's that he mentioned, many others actually. And it may be, it's kind of in progress, very nascent, but this is sort of where I'm coming from. And also NSF actually supports this. So for instance, they just issued a $50 million initiative or something like that. So to support these types of initiatives. So, and well, AI will definitely play a role in this platform. And now let me give you a few examples. So first of all, I should say categorically that we should not use AI to peer review papers written by humans. But where AI can be useful is sort of as an editor. Basically, what is that we want, for example, as an editor, when I receive a paper, I look at the paper, I obviously don't want to read it, and I say, well, I'll send it to, I don't know, Victor Gurari for review. And he will say, no, thank you very much. But in general, I kind of rank, so the input data is the paper, the output data are people who are actually interested in reviewing this paper. So if you think about recommendation engine, so if you want to go through the data every morning, let's say you just see the time-ordered link list of archive papers. But suppose instead of that, you would see some Netflix-style sort of recommendation of papers, which actually are specific to you. So in between, there is a matrix, essentially, which the input is the researcher, the output is a list of papers, and vice versa. So these are inverse processes, actually. So this choosing referees for papers and choosing papers to read are, in fact, the same problem, which could be solved with AI. Now, also, we kind of played around with this. It's a little silly, but I mean, one thing that we also noticed is that every once in a while, we receive papers which say that there is a room temperature superconductivity. So, and actually, I mean, it happens every maybe 3 months, and I'm actually moderator in superconductivity in archive. And most of them are completely ignored. Nobody cares. But this one, LK99, you might have heard about it. Actually, the story here, well, basically, one of the things we built actually with this project is that it helps with accessibility, and actually it's kind of AI tools. It's not like very sophisticated AI, but basically you can take your paper, you can just do it, now if you want, connect to archive through API. It will extract the image, extract the text, cut it into pieces, process through an LLM, generate an audio video summary, and sort of connect it to archive. And that's, for instance, the paper I was presenting earlier today. So if you go down, you will see a lot of, actually, some of them are AI tools associated with papers. You can use them today, not just our stuff, but many other people's stuff. So LK99, what happened was actually the director of archive, Stein Sigurdsson, contacted me and said, is it for real? They said LK99. I looked at the paper. So it was not really very suspicious. So, but the authors were mentioning a video. I asked them for the video and actually put it on my own server and connected it to archive. And then in the middle of the night, I checked my phone and it turned out that I actually got a $1,000 bill because 1 million people access the video. So this tells you that if you want actually your papers to be read, so maybe that's a new way people actually disseminate information. So we built also a few other things where you can talk to the paper. I know that your startup does that. So, and this is actually very useful. Sometimes you can just ask documents in plain English and it answers. So I mean, this sort of thing, but it is basically off-the-shelf tools. There's nothing fancy there, but it's just an example of tools that are being developed in the framework of this so-called archive labs. So more interesting, and this will be my last slide, I think. So I just finished it like 5 minutes ago. So, more interesting AI-related projects is decomposition of papers into facts. So what one can do, and actually it's very interesting, is they can input document, which is a paper, and then out comes a set of facts. So this is done by Yasin Brahimi, who's pretty well known actually in the AI community. So, and you can consider also, for instance, you take two papers and you can look at the similarity and contradiction indices of these papers. So let's say basically take a paper, decompose them into facts. They're like two vectors in some space. And well, are they parallel or orthogonal to each other, for instance? So this is a useful use of AI for processing documents. So another thing, which I'm not an expert on, but there is a guy who works on that, is building a so-called ontology, not to be confused with oncology, which is basically a knowledge network. And in a sense, it came, well, it's very important, for instance, it was very important in the Human Genome Project, because, for example, there was, like, for instance, some researchers, let's say, I don't know, in Australia would have discovered a new gene, and then some researchers in the US would discover the new gene. How do they know it's different or the same? So this sort of classification scheme was part of this ontology, and this is done also for archives, so by John Beverly. So another thing which is potentially interesting is predicting impact of papers through new metrics, not related to citations, because citations lag and sometimes they're just ceremonial. So this is an interesting project, flagging low quality content and potentially unphysical or fraudulent data. AI can be helpful here. While tracing ideas to original sources, like you cannot, oh, I've heard that E is equal to MC squared, but I forgot who came up with that. So AI can kind of trace it back and see, oh, it was Einstein. So, and well, I mean, this is a question to which I don't have the answer. So potentially, and down the line, maybe it's something that can generate new ideas. So anyway, so who is involved in this project? So it's Stein Sigurdsson, who's actually science director of archive, myself. So this guy who is an expert on knowledge graphs, some very good developers. Also, I think she used to be here, their advisors. So founder of bioRxiv and medRxiv, Richard Sever. This guy is Arslan Farouk, is a product leader at Google Cloud, very experienced entrepreneur, and Charles Clark, who is actually, I think he was an advisor of Anna Marie Ray, but he worked with DoD and NIST, and he's an expert on policy. So anyways, a good group of people. So, and I would be happy to answer any questions. Thank you.